This is a key to the worksheet on graphing a piecewise function, and you have two functions here, f of x and g of x, and notice that both of those functions have two parts. Now remember, if you look at the first one, just to remind you, so I'm going to go ahead and rewrite it so it's a little bit clearer. So f of x, so this function f of x is equal to 3 if your domain is greater than 2. And then f of x equal to x minus 2 if the domain is less than or equal to 2. So when graphing a piecewise function, you need to look at each part individually. So let's look at that first part. So I'm going to refer to this as y equals 3, and my domain is, I'm going to use this part when x is greater than 2. Now remember in our discussion, whenever we're going to go ahead and use a t-table, but whenever you use a t-table or whenever you're graphing each part, it is very important that you use this number that you see here, whether or not there's an equal sign. So since there's no equal sign, you're still going to use it, but when you use it right here, when you let x equal 2, and you get that point that corresponds to this part here, to this equation, remember, you're gonna use an open circle. So an open circle, since there's no equal sign. But remember what this part right here means. Remember this, if the domain was all real numbers, instead of what you see here, if the domain was all real numbers, remember y equals 3 is a horizontal line. So y equals 3 is a horizontal line that intersects the y-axis at 3. So what that means is that no matter what x is, my y coordinate, my y value is always going to equal 3. So when x is 2, my y value is 3. And then I have to just go ahead now and pick another value for x that's greater than 2. So you make sure you're using a number that's in this domain. So you got to use numbers that are greater than 2. Even 2, although 2 is not greater than 2, that's why we use an open circle. So if x, let's say, is 4, if x is 4, y has to equal 3. No matter what x is, y is equal to 3. So notice all along here, if you went ahead and you did some more points, let's say x is 5, y will equal 3. All right? So that's what that means. So if we go ahead now and graph 2 points, and remember, this is a y equals 3 is a line. If the domain was all real numbers, y equals 3 is a line. But it's not all real numbers here. It starts at whenever x is greater than 2. So at 2, 3, you're going to use an open circle at 2, 3. And then another point we have is 4, 3. So I'm going to have 4, 3, which is a point on the line. So notice I'm going to put a closed circle here. And I'm going to shade every number, every real number to the right. So that part here is the graph of f of x equal 3. So that's what we just graphed. So we just graphed this part here, f of x equal 3 if x is greater than 2. And you can see that the domain for this part of the graph here is greater than 2. See, this is 2 here, and so I'm going from 2 to infinity. All right, so that's the domain. For the next part, f of x equal x minus 2 if x is less than 2, let's go ahead and do that. So this time we have y equals x minus 2 if x is less than or equal to 2. So again, as we discussed a while ago, when using ordered pairs and using points, always make sure you use this number you see here, regardless of whether or not you see an equal sign. I do see an equal sign here, so when I let x equal 2, I'm going to use a closed circle this time. And so when x is 2, I'm going to substitute the value of 2 into x here. See, there was no value of x here. There's no x here, but there's an x here. So when x is 2, I get y equals 2 minus 2, which is 0. Now remember, if the domain, if all you were asked to graph was y equals x minus 2 and not restrict the domain like we are with a piecewise function, that will be a line, right? A line with 2 arrows. But that's not what we have here. We have a restriction. So you need to be a little bit careful when graphing this. It's not a line like you would think with 2 arrows. All right, so I need another value of x that's less than or equal to 2. So let's say 0, right? If x is 0, I get y equals 0 minus 2, which is a negative 2. And remember, that's really all I need because I know that this is a line. Well, let me rephrase it. If the domain was all real numbers, I know this is a line, and I just need 2 points to graph a line. But it is restricted, but I still need 2 points. That's all I need is still 2 points. All right, so let's go ahead and plot the point 2, 0 and 0, negative 2. So 2, 0 is here, closed circle. And then 0, negative 2 is here, closed circle as well. And then let's go ahead and graph that part of the graph. And you're going to notice that this is a ray as well. So you have this ray. So both parts here are rays, not lines like you would think of, but rays because your domain is restricted for each part. Notice it's a function, right? So this is a function, so make sure it still passes a vertical line test. For each x coordinate, there's got to be one y coordinate. Even at 2, it's still okay because notice when x is 2, my y value is 0, not 3 because that's an open circle. All right, so I'm still okay here. When x is 2, there's only one y value, and that is y value of 0. All right, so that's the graph of number 1. Now let's go ahead and do number 2. So number 2, we have, let me go ahead and write it here. So this is what we have for number 2. We have g of x is equal to x squared if, and then x is less than or equal to 1. And then 2x if x is greater than 1. All right, so that's my piecewise function here. Just like we did in the previous problem, we're gonna look at each individual part. So y is going to equal x squared when the domain is less than or equal to 1. And so let's go ahead and do that. Now notice that in the previous problems, if you did not look at the restriction, if the domain was all real numbers for each part, those are lines. But remember, y equal x squared, if the domain was all real numbers, that's a parabola. All right, so that's a parabola. But the domain's restricted. So you got to keep that in mind. But the point also I want to make is that y equal x squared is not a line. So don't draw a line. That's a parabola. It's got to look curved, okay? And keep in mind of the restriction here. All right, so let's go ahead and do this. So just like our discussion earlier, you must always use this number you see, regardless of whether there's an equal sign or not. There's an equal sign here. So that means that when I plot that point, I'm going to use a closed circle. So a closed circle. So when x is 1, I get 1 squared, which is 1. Y equal 1 squared. And I need some more numbers for x. And you got to, now in the previous problem, all I needed were 2 points, 2 values of x. Here I need a few more because that's not a line. That's a curve. All right, so if x is, in this case, since the restricted will be part of a parabola. Notice I said part because the domain's restricted. If x is, let's say, 0, I get 0 squared, which is 0. If x is, let's say, negative 1, I get negative 1 squared, which is 1. If x is negative 2, I get negative 2 squared, which is 4. If x is negative 3, I get negative 3 squared, which is 9. And I'm going to stop there because notice my y value for my grid goes up to 11. All right, so let's go ahead and plot these points. So I have 1, 1, 0, 0, negative 1, 1. So here's what I have. I have 1, 1, closed circle. I have 0, 0, the origin. I have negative 1, 1. I have negative 2, 4. And I have negative 3, 9. All right, so since the grid's given, I expect you to find those points. All right, and so this part of the graph, remember the parabola looks like this, x squared, right? But remember, you're not going to draw x squared. Don't draw a whole parabola because the domain, remember your domain is from negative infinity to 1. So your domain is from here to here, and that's where it stops. Okay, so the graph is only going to appear on this side, not both sides of x equal 1, just this side. All right, so then you just draw something that looks like this, make it look like a parabola, or part of a parabola rather, and you get something that looks like this. Okay, so that's y equal x squared. Now let's go ahead and do y equal 2x. So now y equal 2x. Now we know y equal 2x, if the domain's all real numbers, is a line with slope 2. The slope would be 2, but it's restricted. The domain's restricted. So I'm not going to look at a line with 2 arrows. I'm going to be looking at a ray this time. As we talked about earlier in all these problems, I must use this number as c. Even though there's no equal sign, I must use that number. So when x is 1, I'm going to use an open circle when I plot that point, though. When x is 1, I get y equals 2 times 1, which is 2. Now remember, if the domain's all real numbers, so if the domain's all real numbers, I get a line. Since the domain's restricted, there's going to be an array here. So it goes from x greater than 1, so 1 to infinity with an open circle. So it'll be an array. So I just need 2 points. So I just need to find another value of x greater than 1, so let's say 3. If x is 3, I get y equals 2 times 3, which is 6. So let's go ahead and plot those points, 1, 2, and 3, 6. Notice that 1, 2 is going to be open, though. So here's 1, 2, open. And then here is 3, 6 right here. Let's see, 3, 6 right here. And then draw your array, and it looks something like this. Okay? All right, so that is the key to this worksheet on graphing piecewise functions.